Welcome to Counter Surveil, where we dissect digital warfare with the finesse of a nation-state APT and the subtlety of a rootkit in your CI/CD pipeline. Now, normally we ease into things with a bit of foreplay, warm up the guest, build suspense. But today, no. Today we're going straight to the main event. Our guest is Joe, but you probably know him by his more ominous handle, Moloch. If that name doesn't ring a bell, then I regret to inform you, you are not invited to the cool side of the network. This is the guy who wrote Sliver. Yes, that Sliver, the command and control framework that red teams live by and blue teams quietly fear. It's open source, it's modular, and it's currently haunting a threat matrix near you. From internal pen tests to APT-grade ops, Sliver is everywhere, and Moloch is the one who put it there. His GitHub commit history, more active than your company's SOC at 3 a.m. His toolsets, sharper than your CISO's hairline budget cuts. And while you're still refactoring your YAML files, he's already published another article, given a talk, and casually built a CTF framework, Root the Box in case you were wondering, that's used to train hackers who will someday own you. You've probably read his work, whether you realize it or not. And if you've red-teamed anything that mattered in the last few years, there's a decent chance you've stood on his digital shoulders. Possibly while he was still pushing code underneath you. He's a constant on the conference circuit, a ghost in the GitHub machine, and somehow manages to stay both wildly prolific and maddeningly humble. So today, we're going to try something really bold. We're going to see if we can actually make Moloch blush. So dim the lights, secure your endpoints, and maybe, just maybe, pull those outbound rules a little tighter. Because this is Counter Surveil, and our guest is Joe DeMercy, aka Moloch. Let's get into it.
You know, they're always cheesy, but that one was special. Just for you, Moloch. Are you blushing yet? Are you?
A little bit, yeah.
Intro. Okay,
yeah,
sweet.
That was awesome.
We have to deliver on our promises to our viewers.
Yeah.
I think the AI model it built for you actually looked a little like you too. That was pretty cool. That's nice.
It tried. It
tried.
I
A
don't
little
know.
bit. A little bit. They got
I
the
see
last
what
one
was
right.
Typed in generic IT worker because when I walk around San Francisco, I see copies of myself too. So I think the model didn't have to try very
That's called
hard.
OPSEC. So. Don't worry about it, man.
So all right.
Looks like Twitter's not letting us go live there, but we are live on YouTube. All right.
Oh no, I guess Twitter's mad about me saying the F-bomb so many times. God fucking damn it. I
sorry. I just forgot to renew my premium subscription because it's
it's actually just because you called it Twitter instead of X, and so you're banned now. Yeah.
I'm dead naming Twitter until they ban me. They can try me. And I'm not calling it Zitter either.
I'll just pop it over to something else. Let's see. I'm gonna pop it onto Twitch just for the lulz. All right, and Ed CrowdStrong.
I hate Twitch.
The blue team has arrived. So I actually have to behave myself now.
No, you don't. So, Joe, welcome to the cast. Sledge was going to do your intro after I played that horrible AI video. So, Sledge, go ahead.
Well, I was just going to say, Moloch, if anybody doesn't know who you are, what's an elevator pitch, brief intro about yourself? And then I got some follow-up questions.
Sure. Yeah. So I'm a principal consultant on the red team at Bishop Fox. I help manage sort of the technical aspects and technical execution of red team projects in the red team practice at Bishop Fox. Prior to actually helping start the red team practice here at Bishop Fox, I worked in application security for about 10 years. And so I did a lot of stuff in AppSec and been doing red teaming for a few years now too. And yeah, I went to college with Sledge, so that's how I know him.
So
nice.
The follow-up question for you. Let's just jump into it. My follow-up question would be like, what's your come-up story? We've all got one. Like, what led you to going to the same college as me?
Yeah, so I've actually only had two jobs in my entire career, which is I worked at the Geek Squad, so at Best Buy Geek Squad, and then in college I've actually been at Bishop Fox for over 13 years now.
I remember.
But yeah. But I don't. I actually just so I was working at the Geek Squad, and actually I just was like one day I just kind of got bored, and I was like, I should probably like do something with my life, and so I ended up going to DEF CON because I was like already interested in like security stuff from when I was younger, and so I ended up going to DEF CON, and the college that Sledge and I went to happened to have a booth at DEF CON, and so that's how I kind of ended up there, and then Bishop Fox, which was Stack and Lou at the time. Uh, Went there. It came to our school to recruit folks, and so they ended up hiring a friend of mine. And they didn't. I applied, and they didn't take me at first. And then my friend eventually referred me. Yeah, you still have that T-shirt.
Yeah.
And so a friend of mine referred me, and then I got hired at Stack and Lou. And then a few years later, Stack and Lou rebranded to Bishop Fox, and I've been around ever since. And started as an intern, and now I'm one of the managing principals. So that's kind of a brief history.
So, how was it like at the college?
I had a very interesting.
You were a CS major, right?
Yeah, so I studied computer science, but I hung around all the NetSec folks because I always had an interest in security, even before going to the school. But I wanted to get a computer science degree just because I thought it would just be more broadly applicable in industry. And I really always sort of focused on application security, especially early in my career. I did almost all application security stuff. So I studied computer science. I had a very interesting college experience, and overall very good. Though we started a club, we had started a hacking club at the school, which was really fun, which led to the CTF that we sort of started, which was called Root the Box, and then I wrote software to sort of manage that, and that was like one of the first open source projects. Or pretty serious open source, or I should say moderately serious open source projects I started. And then actually that actually has been maintained by El Jefe on GitHub for probably the last 10 years. So I haven't been too involved in Root the Box in a while, but we started it when I was in college, and I still see it around at conferences actually. So actually, even 2 years ago at CactusCon in Phoenix, they were using Root the Box, which was funny. So I still see it around, which is great. It's had surprising legs as a project, but I haven't been too involved in it in probably 10 years. So.
And if anybody's wondering what Root the Box is, it's kind of like Hack the Box, but self-hosted before Hack the Box was a thing. So basically, the idea would be it's a scoreboard where you download stuff from VulnHub, add your own things, and put your own flags and stuff. Put it in the scoreboard, and you can keep track. And then it evolved over the years. You can do like be cops and robbers, and it was pretty freaking cool. We actually used it at IBM for the longest time for training.
And
actually, one of the challenges
specify. Oh, sorry. Go ahead.
Oh, I was just going to say, actually, one of the
scoring system, right?
Yeah. So Root the Box is sort of the open source scoring system. It manages the flags. Teams can submit flags, and it will score them and everything. But you have to bring your own challenges to it. But actually, one of the original challenges that I wrote for Root the Box in 2011 is still used by Bishop Fox as part of our interview process, although we were supposed to be retiring it this year. But that has also had surprising legs on it. We've been using it for probably 12 years to do interviews. So, but like I said, I think it'll be retired soon. So
That was totally not a hit
Get
for anybody
your
interviewing.
this week
Yeah.
before he retires it.
Yeah,
So
yeah.
you know
Well,
what
I'm not
Bosco has
going
ahead
to
of
give
time.
away any of the answers to it, but there's the saying that no temporary solution is ever temporary definitely holds water, because we're like, oh, we'll just use this and then we'll write something else, and here we are a dozen years later, and we're still using it. So.
Yeah, to my knowledge, the last time I heard, Root the Box is still sitting on some IBM server somewhere.
Yeah, so that's around too. Yeah.
But anyways, I mean, I can't remember what year it was, but I remember in my ex-wife's mom's car running errands, watching the clock because she always listens to NPR, and I was like, I know Joe's coming on in one of these times or any minute now, and then boom, there you are, and I like turn up the volume.
Yeah.
What was that topic on? I don't even remember.
So it was on it was basically on iPhone security. And we get these press requests. Our the Bishop Fox marketing team gets them. Basically reporters will want comment from experts in various topics, and so they'll reach out to different companies and ask to like interview someone. So that was like an opportunity that came through Bishop Fox marketing. And this was around the time of the San Bernardino terrorist shooting.
Yeah.
And they were the FBI was like trying to compel Apple
That's right.
to unlock the phone. And so they asked, and so basically they were asking me about that situation. Is it because and sort of technical nuances around like code signing and things like that, and how the encryption works in iPhones. So, because at the time I haven't done too much iOS stuff in a few years, but I actually did like around that time I was doing like a lot of iOS security work as well. I also wrote like a code injection and co-authored, I should say, code injection and reverse engineering framework for iOS that came out around that time. Although these days just use Frida. It was basically like a really janky version of Frida, but Frida is much better. So you should definitely use that these days. So.
What was it like working or dealing with NPR?
It's super easy. They just called me up on the phone, asked me a few questions, and then that was it. Like it couldn't be easier. Yeah, so that was actually pretty straightforward. I've done a few others too for like Market Watch and trying to think, but I have a list on LinkedIn, I think, because they Bishop Fox likes to tout. If you ever hire us, we provide like professional resumes, and my resume lists all the different interviews I've done. So
I see your name all over the place all the time, and it's like, hey, I know that guy.
Yeah. So I've done a few of them over the years, but I think we did one for. I think I did one for Log4j when that came out. Was like a more recent one. But basically, whenever there's a vulnerability in the news, people want comments, and so you just. But yeah, it's pretty easy.
Do you
They'll
tend to
usually
wear
just call you on the
pants when
phone.
you're on the news?
Yeah, well, that's the great thing about radio is so.
You don't even need clothes.
Oh,
Yeah.
hey.
I've been told I have a face for radio.
Yeah.
So tell us about some of the other software that you've worked on over the years. One of your tools, I think it was iSpy or something like that, or not.
That
iSpy,
was the
but
iOS. Yeah, that was the iOS code injection sort of reverse engineering framework that I worked with a former colleague of mine. Haggis is his handle. So basically the way it worked is you could inject it into the runtime of an iOS application, and it would replace the Objective-C message send function, which is basically in Objective-C how functions get translated from like in the code. Basically functions get dynamically resolved using this method. And so if you use that, you can basically intercept every function call in the Objective-C runtime and sort of log it or redirect it. And so we would like inject an HTTP server, and then use a WebSocket to stream all of those function calls to like an HTML like front end. And so you could use it to replace or log function calls to help reverse engineer applications. So, like I said, kind of like a janky version of Frida, but this is before Frida existed. So.
And then what was that tool? I think it was you, the one that analyzed screenshots from, I think, GoWitness and Eyewitness.
Oh, yes. So that model, that was some of the early AI work that was actually done by another colleague of mine, Alta 4. He had created,
I
and this
know
is
him.
before, yeah, this is like before ChatGPT or anything. He had created an AI model that could identify like login pages and stuff. So you would run GoWitness or whatever and to collect a bunch of screenshots, and then it could categorize them for you. So it could put them into login pages, 404. Actually, one of the more useful ones that I think we still use is old looking. So it's trained to like recognize pages that looked old, which often corresponds to old code. Old code tends to have more problems. So it's like a really nice way to sort of triage. If you have like a large network with like a lot of HTTP services, you can sort of triage what you want to look at. It's also quite good at like finding login pages, which again, especially on like an internal network, or if you have a broad sort of like external perimeter that you're looking at, just finding login pages and throwing admin into them, it can be very efficient at something like that. So, but I basically took that model and built it into an Electron application called Electric Scan, and it basically uses multi-process Electron windows to do the screenshots, and then the model is also built into sort of like the screenshot tool, and it gives you a nice little GUI to do everything. And actually, one of the fun things I learned on that project is, I had benchmarked it against the Alexa Top 1000 because I was like, I want to, performance-wise, you have to test these tools. And so I was like, all right, I'll just take the Alexa Top 1000 and I'll go take screenshots of all of that. But what I learned very quickly is that when you run Electron windows, even if the window is invisible, the audio is still enabled. And there's a lot of websites in the Alexa Top 1000 with adult content, and if you don't mute those windows, it all plays at the same time, which was a very something I learned very quickly. So if you're ever benchmarking your security tools against the Alexa Top 1000, make sure you mute the audio on the non-visible windows used to render all of that, because it will play without user interaction. So, and don't do it in an office either. You might get a lot of weird looks. So.
Do it in someone else's office for best results.
Yeah.
I remember I had a tool that's similar to that back in the day that would do RDP connections and then try to do like the utilman or the other bypass, and then take a screenshot and identify if it worked or not based on if it saw a command prompt. That's cool shit, man.
Yeah, if anybody's doing internal tests with like a shit ton of web apps, use that tool. It's super useful.
Yeah, you got to remember the name of it. There you go. What's the name of it,
Yeah,
Joe?
Eyewitness.
Electric Scan.
Electric Scan.
It's called Electric Scan.
If I ever make show notes.
And it's on my GitHub. I haven't updated it in a while. I'm pretty confident it still works, but
I still use
it. Do you? Okay, yeah. So I guess it still works. I haven't had a chance to update in a while. Maybe I should go back and update it. Because I did use it. I have used it quite a bit on internal engagements, but less so on red teams. I put the link in the chat there too. So,
before we move on to the main event, are there any other pieces of software that you've worked on worthy of talking about?
I wrote something called Burp Multiplayer, which I really like. But
I saw your name in the Burp Suite store, like the BS
store. Oh, there's
store,
that too, yeah. Yeah, so there's CSP bypass, which is a content security policy analysis extension that I wrote for Burp. That's in the Burp App Store. I also wrote Burp Multiplayer, which basically synchronizes Burp state between multiple users. That one I couldn't get in the App Store or in the Burp App Store because it requires an external service. You have to set up a RethinkDB container. But I really like that tool. I think it's cool. And then I also wrote another just popular-ish GitHub project is LeakDB. So LeakDB is sort of like a plain text have I been pwned search. So you can use it to index leaked data sets. And then it can basically look up username, password. So if you like give it an email, it can very quickly. So for example, if you have like say 2 terabytes of data, it can search it in about 1/10 of a second. Once it's indexed and everything, indexing it might take a while, but once it's indexed, it can search it in about 1/10 of a second, and it can pull out the plain text passwords associated with that email.
So basically, let's say we have the NVD database breach or whatever it was called, and that tool would work to search through that real quick.
Yeah, so you basically normalize all the data, and then it will calculate indexes for it. And then once it has an index, it can look up like offsets in the file really quickly. And you can run it as a service too. So that way, multiple people can sort of access the same data set. So.
Cool.
That's really cool. I tried to build something
That's
like that
useful
years
as hell.
ago using Elasticsearch, and it did not go well.
Yeah. So so basically that was the challenge we ran into is when you have several terabytes of data, traditional databases, I mean, you can scale Elasticsearch and stuff to like these levels. It's very expensive. You need a lot of hardware to do it. Same with like Postgres. A lot of people might reach for like a database, but when you have 400 million entries that you want to put in the database, Postgres, you need a lot of hardware and a lot of expertise to scale Postgres and stuff that way. So LeakDB is basically a custom index implementation that gets around those problems by so it has basically 2 modes. You can use data lakes like BigQuery or Athena on AWS to search through the data once it's like normalized and everything, or it can calculate indexes itself. And it uses external parallel quicksort to do that. So it will use as much memory as you have, and it will basically load chunks of the data set into memory, sort it, and then it will basically merge those chunks once they're all sorted to get a sorted index. And then it uses binary tree search to look up entries. So it's very fast, it's very efficient. And it's actually significantly faster than most databases and stuff, even if you scale them to that, because it only solves one particular. Databases have to like interpret SQL and everything, and really we're just looking up specific values. And then the other thing it does is it uses a configurable Bloom filter to remove duplicates, because especially when it comes to data lakes, the cost of running a query is based off of how much data that query consumes. And so by removing duplicates, you significantly increase the cost efficiency of querying the data set, because there's a lot of duplicates. And so by eliminating those, your query consumes less data and is more cost efficient to run. So.
Very cool, man. How do you go about normalizing the data when you're doing it? Like, what's your process?
So it has several different modes. So there's actually an example Python script to write your own normalizer, but it basically normalizes it into JSON delimited, new line delimited JSON. So you have basically a text file, and each line is a JSON object. These are the formats that are typically consumed by BigQuery and Athena, although it also supports Parquet. So you can also normalize the data into Parquet, which is used with Athena. Again, it's more cost efficient to do it that way. It's about 30% cheaper per query on Athena if you use Parquet versus JSON new line delimited formats. But it supports both. And there's a Go implementation as well as a Python implementation to convert the very non-standard formats that various hacking groups release leaks in. But it can take colon separated value, new line separated, semicolon separated. You kind of just use the different parsers. It'll normalize it, then feed it through the Bloom filter to try to determine if it's a duplicate entry. And then if it's not, it'll write it to the output, and then you calculate indexes based off of the output of that. So
That's pretty freaking badass, man. Very cool project.
Yeah, it's definitely one of the more interesting ones because normally you don't really have to like most data sets, especially in security, like aren't big enough where you really have to like get into data structures and sorting algorithms and stuff like that. But in this case, like you really do need to apply some of those very computer sciencey techniques because you're dealing with hundreds of billions of data points. So it's kind of an interesting project and challenge from that standpoint.
Hell yeah, man. Very, very cool.
Cool.
Shit. So I got some canned questions for you.
Sure.
What drove you to create Sliver? Like, and philosophically,
Mhm.
design-wise,
Well-
how does
well-
it like diverge from other C2 tools like Cobalt Strike? Sledge, obviously, you wanted to interject, so why don't you say something first?
No, I was just going to have him give an elevator pitch for Sliver, and then we get into the questions.
If people don't know what Sliver is by now, then they need to crawl out of the rock.
Dude, surprisingly, some people don't know. I couldn't believe it.
Yeah, so the elevator pitch is Sliver is an open source command and control framework. It's designed for professional red team use, and it's written in Go. So to answer one of your questions, one of the main one of the early motivations was Cobalt Strike is a very Windows centric C2 platform. Great tool, by the way. Nothing against Cobalt Strike. It's a great platform. I've used it in the past quite a bit. But it's very Windows centric. It's really designed for Windows networks. And especially Bishop Fox, we have a lot of clients in sort of like the San Francisco Bay Area, a lot of tech startups, very hip cultures. They're using MacBooks and AWS, and often we'll get engagements where there's not a Windows machine in sight, let alone like an Active Directory or anything like that. And so we really needed a command and control framework that we could use not only on Windows, but on Mac OS and in Linux environments as well, and across multiple CPU architectures. And I really liked Go. And actually, at the time, I was reading a lot about, or I was thinking a lot about the trusting trust problem. So Ken Thompson's 1984 ACM acceptance paper around backdooring compilers. And Ken Thompson is one of the creators of Golang. And I had this idea of like creating an implant that could like recompile itself. And so then you could pivot between like a Windows machine and a Linux machine by just having the implant like recompile itself and copy itself over. And I wrote sort of like a prototype of this in Go because Go's compiler is written in Go. So the Go compiler is like very portable. And since it can compile itself, it's like very easy to recompile like Go with itself to go to different architectures and stuff. And so what I did is I took the Go compiler and all of the tooling with it and embedded it into the implant. And then I embedded the source code of the implant into itself. And it did work. I did end up with like an implant that could recompile itself and go copy itself across machines. And I had this idea like, oh, maybe this could be used for like polymorphism. But beyond the trouble with all of that approach was the implant ended up being like 300 megabytes, which just wasn't super realistic. And I mean, to this day, like Sliver implants tend to be, on the thick side. But that kind of just evolved into what if we took the Go compiler and embedded it into the C2 server, and then it could dynamically build the implants. And so that was kind of the initial thought around that. I also really wanted to use like mutual TLS because other C2 frameworks, and many even to this day, the implant doesn't authenticate the server. There's no like mutual authentication that occurs. You can use like paranoid mode and stuff in like Meterpreter and Metasploit, another fantastic framework. But it wasn't like super easy to configure that stuff. And you really had to go out of your way to use it. So I really wanted something that was like secure or like used secure by default. And when combined with this sort of like dynamic compilation system that we had sort of built for that implant prototype, it was very easy to embed X509 certificates and other types of credentials directly into the source code. And the other advantage of this is once you obfuscate the binary, it's also harder to extract those configurations. So a lot of implants, the way that it works is it'll take the entire configuration section of like, what's your C2 server, what different settings did you enable and stuff, and it will like append it like in a contiguous section onto the end of the binary or onto the end of the payload or something like that. And the disadvantage of doing it that way is it's very easy to extract the entire configuration because it's all like in one place. It makes it very easy to implement dynamic configurations, makes it easy to parse and everything. But at the same time, if someone's reverse engineering your implant, they can like just pull out all of the settings like that. And so by dynamically inserting and conditionally removing everything at compile time, it makes it much harder to go in and pull a lot of that. You still can go in and pull all of that stuff out, but it's a little more annoying because it's scattered across the binary. And then when you apply obfuscation on top of that, it's generally a little bit more effective because not everything isn't all in like one location. So, so yeah, and then it's sort of grown from there. I should also mention, I've had a lot of help with Sliver over the years. Many of my colleagues have made significant contributions over the years. So it's not like just me writing all this stuff. And we've also gotten some really great open source contributions over the years too. So.
And I was looking at the GitHub today and I noticed that you got WireGuard in there now.
Yeah, so WireGuard, I'm actually a really big fan of the WireGuard protocol in general. The creator of WireGuard, if you go watch his DEF CON talk, he talks a lot about how WireGuard, which is a VPN protocol, actually came from a Linux rootkit that he had written, I assume for a government agency or something. And they had sort of taken the protocol out because they're like, oh, this would make for like a nice VPN protocol too. And the design philosophy for WireGuard is very good. One of the really cool properties of WireGuard is that it's like a single, like every packet is cryptographically signed. So it's actually not possible to use port scanning to determine WireGuard endpoints, because if it gets any authenticated packets, it just drops them and it's UDP. So basically, a WireGuard listener is indistinguishable from a closed port if you don't have cryptographic key material. And so one, that's like really good security property, right? Because you can't use port scanning and stuff to determine those endpoints. Whereas with like an open VPN endpoint or something, you can. But also, so it's great from like that perspective. It eliminates things like, what is it? The fingerprint, TLS fingerprinting and stuff, like all of that stuff goes out the window. There's no way to do JARM fingerprinting and stuff like that. And so from like an operational security perspective, it's in a command and control framework, that's quite useful as well. Yeah, it's just a really well-designed protocol. Also, like fun story, the Go implementation of WireGuard actually contained a reflective DLL loader, and that to this day is the DLL loader that is used in Sliver on Windows, because it ended up being like one of the better reflective loaders, and it just happened to be, I think they removed it in a more recent version of WireGuard Go, but it happened to be in WireGuard Go. We were just like reading through the code, and one of my coworkers was like, "There's a DLL loader in here," and it ended up being like a really good one. And so we actually use that to reflectively load DLLs in Sliver even now. So yeah, WireGuard, excellent option for UDP based C2 communication. Highly recommend it. And we actually took a lot of those ideas and implemented them in some of the other protocols. So for example, the HTTP communication that Sliver uses is also now a single round trip key exchange. So if we receive an HTTP request that we can't cryptographically attribute to one of the implants that particular server has generated, we just drop the request outright. And that actually makes it a lot harder to fingerprint the HTTP listeners as well, although it's still kind of possible. We also randomize the TLS cipher suites for HTTPS listeners, which reduces the ability to do like JARM fingerprinting and stuff, at least for the HTTPS listener. We don't bother with like the multiplayer listener. So firewall those off if you care about that. But actually, if you go look on GitHub, like a lot of the JARM fingerprints are actually just for the multiplayer listener, not the C2 listener. And the multiplayer listener is just for operators to connect to. So you can easily like firewall that off if you don't want people fingerprinting your servers.
So speaking of WireGuard, we've got a video should be in queue. Do we have that ready?
Yeah, I'll play that in 1 sec. Just before I play that, I wanted to go back to when you said the 300 meg around for the payload. That reminds me of something I saw over at Wild West Hacking Fest. It was a talk by Mike Saunders where he was talking about jargon and Jigsaw, which do some shellcode obfuscation, which is really cool stuff. And they provided these benefits where essentially you're using dictionary words that's reducing entropy in your loader, and you're sidestepping like entropy detections. Really cool shit. And then so it's good at evading detection, but it makes a big binary.
Yeah, so Sliver uses that, as well as, man, like 8 years ago now, I wrote another tool called wire transfer, and wire transfer uses that. I haven't seen that. I don't know if I invented that technique, but that was the first wire transfer is the first time I had seen it. So yeah, I'd seen a lot of entropy checks, especially on like during or like packet analysis and stuff. And so wire transfer is actually HTTP smuggling. So we actually used it for email attachments to attach malicious things to emails, because it can generate a .html file that contains all of the English words, which are really like, and then there's like a single JavaScript function that converts it back to a binary. So at least at the time, email security tools weren't very good at analyzing HTML attachments. So you could attach that and it would just look like, and if you did an entropy check and everything, it'd look just like English text, because it was. But then if you clicked on it, it would open it in the default browser, and then the JavaScript would run, and then it would convert it back to a binary, and you'd actually just get an exe pop out the other end. So we initially used that encoding technique for HTTP smuggling for email attachments. But then when we went to write Sliver, we were like, well, might as well throw it in as like a wire encoder, because Sliver will like randomly select different network encoders when it sends traffic. And so that's one of the encoders that Sliver uses too.
Oh, I didn't know that. I also thought like the Jigsaw thing he showed was pretty cool, where he's using Python, the shuffle function, to like create a randomized array of shellcode and then reconstructing the original shellcode later. I thought that was pretty badass. I didn't realize you had built something similar. That's also really freaking cool, man.
Yeah, I think a lot of people have come up with that idea. Defeating entropy checks, actually, I feel like that's kind of, once you think about that problem, that's kind of like the obvious solution. Yeah,
So I'm going to play this stupid little fake ad that we've got here that the guys are asking me to play.
Okay.
As soon as I can find which one it is.
All right. It's relevant, trust me.
Oh, you want to protect your precious data from the prying eyes of your ISP, the NSA, and your nosy neighbor? Well, good luck with that. But if you insist on not being a sheep, roll your own fucking VPN is the way to go. First, go buy a VPS. Don't worry, it's not like you're renting a server to host your illicit activities. Or are you? Then, install WireGuard. It's like setting up a secret underground bunker for your internet traffic, but without the risk of being raided by the feds. And the best part? You get to deal with all the fun of configuring your own VPN. Who needs user-friendly interfaces when you can spend hours debugging config files? Just generate some keys, set up your server and clients, and voila! You'll be encrypting your traffic like a pro. Or, like a script kiddie trying to hide their torrenting habits. So why pay for some overpriced VPN service that's just going to sell your data anyway? Roll your own fucking VPN. It's like DIY for your digital paranoia. Trust me, it's a blast. You'll be the envy of all your friends who are still using public Wi-Fi without a VPN. Losers, roll your own fucking VPN. Secure. Fast. Pain in the ass.
This is why Frank should not have access to AI video generators.
No, this is why Frank absolutely should have access to AI video generators. Also, we actually do have an affiliate code.
No. Bad.
No.
Oh, man.
So, in terms, let's get into the Sliver stuff a little bit more here. In terms of Sliver and the technical capabilities and all of that, let's talk about the UI for a minute. Like, you've got users, agents, Like, what's the difference between like Cobalt Strike, Metasploit,
Sure.
stuff like that?
Yeah. So where to begin? Uh, Sliver addresses multiple use cases, honestly, so the Sliver interface, the user interface, so like the operator interface, is largely inspired by Metasploit. I think Metasploit
Right.
to this day is like one of the best security open source projects. Beautiful code, like absolutely, like every time I go read Metasploit code, I'm like blown away by how well engineered that project is.
Yeah.
But so, and obviously, I think we all grew up using Meterpreter. And
Mhm.
Meterpreter is still to this day, I think, a great payload. But one of the at least from like a red team engagement standpoint, one of the challenges with using something like Meterpreter is one, at this point, it's just, I mean, so is Sliver, but there's a lot of signatures for it. But two, it uses persistent connections. So when you're communicating with a Meterpreter implant or payload or agent, there's a lot of different synonyms for this, but it's basically the malicious code running on the target. When you're communicating with it, you're doing it in real time, right? Like you send a command, you get a response back instantly. This is not quite as, so Sliver supports this. We call it sessions, the same way, a Meterpreter session. But often in red team engagements, this isn't necessarily desirable behavior because those connections may look very suspicious, and often the services aren't making these sort of like long-lived connections to specific servers and stuff. So that's where beacons come in. Which we use in sort of like a more generic terminology. So I would use beacon to describe the communication style, but beacon is also the name of the Cobalt Strike implant, just to make things like a little more confusing, which it uses the beacon communication style. But beaconing is basically when an implant will periodically call back to the C2 server, sometimes called like a listening post. But it will periodically, like every 5, 30, 60 minutes, it will basically check in and ask the server if there are new commands that it should run. It will then take those commands, execute them, and send the results back. And this avoids those long-lived persistent connections. It's a really easy way to avoid things like netstat. So I think Cobalt Strike and Beacon originally came from CCDC, which is like a red versus blue collegiate competition. And I've actually been on the national CCDC team as well, which is a lot of fun. But there you have a lot of college kids like constantly running netstat and like killing suspicious connections. So particularly in an environment like that, it helps to use like this beacon communication style. I think if you look at sort of nation state level malware, you also see similar techniques employed there, which I think was the inspiration for that. But anyways, that's sort of like the beaconing communication style. And so Sliver also supports that. And you can actually go from beacon to interactive or to a session as well, which is similar to like in Cobalt Strike if you did like Sleep Zero. But in Sliver, we make a slight distinction between those. The underlying code works a little differently. So in Sliver, you can start with a beacon and then basically tell the beacon to establish a real-time session back to the C2 server. The advantage, I think, and I haven't seen this in too many other C2 frameworks, maybe they support it or not, but in Sliver, you can also switch between different protocols. So you can beacon over like WireGuard and then start an interactive session over HTTPS, for example. So you don't necessarily need to use the same protocol to go interactive, as long as you compiled it into the implant when you generated it. You can beacon over one protocol and then go interactive over another. And by sort of making a distinction between the two, it allows us to kind of implement features like that. So, but Sliver also supports multiplayer mode, which tools like Cobalt Strike and a lot of other C2s also have this, although it really impacts your cost because you have to buy licenses for something like Cobalt Strike. But multiplayer mode in Sliver is basically when you have multiple operators or multiple attackers that you want to use the same server to communicate with a collection of implants. So when you're on a red team, as the name implies, you're often working with other teammates. And tools like Metasploit don't necessarily really allow you to do this. I mean, you can all like SSH into the same server
They
and then jump on a
try.
tmux. Yeah, there's some stuff in there. I think a lot of it gets packaged into Metasploit Pro because they have like a web interface and stuff. And so I think they, again, try to kind of commercialize some of those features, which is perfectly fine. Like everybody's got to get paid. So in Sliver, though, we use gRPC over mutual TLS. And then we use event streams within gRPC to push events to all of the front ends. So you can have any number of operators connected to the same server, you know, up to hundreds, as long as you got the compute and everything for it. And so, and you'll still, and everyone kind of gets like their own interface, but they're all talking to the same implants, and everyone can kind of hack through the same interface, targeting a single organization. And you can even share things like loot. So Sliver contains repositories of things like loot. And so as you're like finding passwords and stuff, you can kind of save them to the server, and then other operators can retrieve that information or use it to execute commands and stuff like that. So we really try to emphasize sort of like some of the collaborative features. All of this is through a console-based interface. I did write a GUI at one point. GUIs are very tedious to write and maintain, though. I might go back and write another one at some point. We'll see. But for now, it's just a console interface for all of this as well. So
Don't do it. It helps
When
us
we're
yeah.
when we're talking about WireGuard, do we have to have, like, let's say we're using that feature, does that get spun up in the actual software itself, or do you need to have your own WireGuard instance running?
No, it gets spun. Yeah, so we use WireGuard Go to basically dynamically create a WireGuard server that everything connects to. You can actually create local, like a native WireGuard interface on your laptop if you want. I actually wouldn't recommend it, but because it's mostly used for like the C2 between the server and the implants. But yeah, you can actually join your local machine to that WireGuard network if you want. And then the Sliver server just acts as the WireGuard server and sends the packets back and forth. But I would mostly just recommend using it as the C2 protocol. So.
Gotcha. Cool.
Cobalt Strike's malleable C2 profiles. They like let operators customize the C2 traffic, emulate legitimate threat actor behavior. Sliver, you have like procedural HTTP C2 generation for dynamic request creation, but it's not quite the same in terms of like the granular customization of a C2 profile that's malleable in there. Are there any plans to like implement a similar feature in Sliver, or do you envision like a different approach for achieving more customizable C2 traffic?
A different approach. So I actually find Cobalt Strike's malleable C2 too limiting. And it's kind of, in my opinion, it's kind of annoying to configure too. So yeah, out of the box, Sliver, if you're just using the stock profiles, we'll just dynamically try to generate as much as possible. It's pretty different. We've actually also recently implemented, this isn't in a release version, but if you compile from source, you'll get it. You can actually dynamically load any number of profiles across different implants. So each implant can have completely different generations. But basically, you just give it the seeds, and then it will dynamically generate everything and randomize it in each request. So we found this to be pretty effective. It doesn't quite check the box of like if you want to imitate an actual threat actor. Other than actual threat actors have used Sliver. So if you just use Sliver, you're kind of emulating those threat actors. Yeah, so
You remember that article?
Oh, there's been a few. But so in order to achieve greater flexibility, though, again, you'll have to compile from source because this is one of the newer unreleased features, but you can actually define custom WASM, which is WebAssembly, callback functions that get embedded in the implant. And these are Turing complete functions that you basically define an encode and decode function. And then those WASM functions are loaded both on the server and the implant. And they'll reciprocally call each other to encode the input and output. So you can actually arbitrarily encode and decode the output using any programming language that can compile to WASM. And like it's fully Turing complete, so you can implement arbitrary logic to your heart's content. And you can even push new functions to running implants. So the implant can actually load additional encoder functions at runtime. So for each check-in, you can actually also push new logic to the implant and completely change its communication style if you want. Although it's like a little, these are very much like prototype, or I mean, not prototype, you can definitely use them, but it does take a little bit of effort to get all this stuff working. But we do ship some basic WASM encoder functions in the current master branch that you can check out. And we're working on extensions to the Armory so that people can download encoder functions from that too. And at some point, we'll also probably extend this functionality to include arbitrary HTTP. So right now, it's just encode and decode, but we'll probably extend this to be like a full HTTP client, and then you'll be able to implement C2 across like Slack or any arbitrary HTTP service that you want. So that's kind of our approach there is
Or like
user
Teams.
defined or Teams. Yeah, any service that you want really, because we call your WASM function, we call your code. And then as long as your code is sending it back to the server and the server has a decode function, that's all that matters. We still handle all of the message encryption and execution of commands and stuff. So you still get all of the features of Sliver, but you can just like arbitrarily redefine the network traffic to your heart's desire, at least for HTTP. I don't know if we'll extend that to other protocols. It's kind of pointless on WireGuard and mutual TLS though, because those are end-to-end encrypted protocols. There's no real way to fingerprint it anyways. So other than like maybe using packet shaping or something, but like your encoder's probably not really going to be able to deal with that. So, but definitely for HTTP-based services, we're planning to implement all of that. And the encoder decoder function stuff is working today, so you can check that out today. But
It's really freaking cool, man. So like looking over the documentation for Sliver, this WASM stuff, is it documented in there already? Like is
no,
that
it's not in
already
the documentation. I gave another presentation on how it works. It's in an unreleased version, so we're still working on version 1.6 of Sliver. Unfortunately, I've gotten sidetracked with internal projects over about like the last year and a half at Bishop Fox. So I haven't had a ton of time to work on Sliver in the last year and a half or so. I'm hoping to finish up a lot of those actually in the next couple months. So hopefully soon I'll be able to go back and finish a lot of this stuff. Some of my other colleagues have been implementing a bunch of cool features for 1.6, but I just haven't had the time to work on it.
how does
But yeah,
how does
so
the decoupling oh
Mhm.
sorry. Go ahead.
Once we finish 1.6, we'll update the documentation to include all this stuff. But for now, you can see that if you look on YouTube, those other presentations were recorded, and there is some. I hate to say that the code is the documentation, but there's a lot of comments and example code in the repo. If you're curious about that sort of stuff, so.
How does decoupling traffic manipulation from encryption enhance both flexibility for operators and security guarantees for the C2 channel? Like, are there trade-offs compared to like tightly integrated solutions?
Yeah, I mean, so we just handle the encryption for you, so that way you get peace of mind, right? Because even though we're red teams, we don't want to be exposing our clients' information and stuff. That's probably one of the nuanced differences between us and real threat actors. That is never something we would ever want to do, is expose client information. Whereas, like, if you're an actual threat actor, you don't really care about that. You can just YOLO all the data across Netcat for But like a professional red team can't really do that. We have to make sure everything is encrypted and securely communicated because we're often, as is often the goal in a red team exercise, getting very sensitive information or targeting sensitive information. So we want to make sure that that's encrypted reasonably well, or to the best of my ability, at least. And so we just take care of that for you. We basically just hand you a binary blob and say, encode it. And then you encode it and we send it back to the server. And then we take whatever blob we got, we pass it to your decode function, we get a binary blob back, and then we decrypt it and we have integrity checks and stuff so we can determine if the data was if we're not getting the same data that the implant set, like we can cryptographically determine that, because we use authenticated encryption and decryption for everything. And we also use ephemeral keys. So the key is not the key material that's actually used to encrypt a message is only ever stored in memory. It's never written to any disk anywhere. There's actually a key exchange that occurs when the implant initially talks to the server, and then that key is unique to that session and is never recorded or written anywhere other than memory. And so you get all of those sort of like security properties. That way, as long as that AES key is destroyed, even if you have like a recording of the network traffic, it's actually not, again, vulnerabilities and stuff within the code notwithstanding, it should not be possible to recover any of the data that was sent, even if you have the TLS private keys and stuff. Which is a property known as like forward secrecy in cryptography. So we try to kind of implement that to kind of the best of our ability. It's not like there's probably cryptographers who could do a slightly better job, and I'm sure there's weaknesses, but we at least try to address some of those types of nuances.
So you guys support a lot of different communication protocols. Like you already mentioned MTLS, HTTP, HTTPS, DNS, and WireGuard. When you guys are doing DNS, how does that differ from like the way that other frameworks that go over DNS work? Because I've seen like one I used to use, I could actually detect that traffic looking at a WireGuard capture, because the traffic on port 53 would then go from UDP to TCP when the packets were too big. Like, how do you prevent somebody from like from figuring out that's what's going on over like the DNS?
Yeah, I mean, it is trivial to determine if someone's tunneling over DNS, but the thing is, you have to look. DNS is mostly useful. Yeah. So I'll make a distinction here, which is DNS can be used for two different sort of use cases, and not necessarily just within Sliver, just like speaking abstractly as a red teamer. You can use DNS for covert signaling. This is where you might want to send like one bit of information, like wake up, something like that, to your implant. DNS is very good for that, and it's actually really difficult to detect DNS signaling like that, because you're encoding such a small amount of information. And you can do things like what is like the third bit in the second octet of the IP address or something like that, right? Like if you're only sending one bit of information, like the less information you need to send, the more difficult it is from a detection standpoint. Now, Sliver is doing like full tunneling, full DNS tunneling. Like we can tunnel DNS connections, assuming, well, actually there's some nasty bugs in the current DNS implementation, but once we fix this, you can do like full tunneling. So we're doing like full communication over DNS. And that there's just no getting around it being easy to detect if they look. And that is a big if. So the way that Sliver encodes information is it basically takes the binary, it base 32s it, or depending on the version, it might try to use base 52 or base 32. Base 32 is used because it's case insensitive, and DNS, the way fingerprinting works in DNS, like it'll mess with the cases. And so even though DNS itself is a case insensitive protocol, various DNS servers will require case sensitivity to do certain types of DNS things. Anyways, so we use base 32 because it's a case insensitive encoding mechanism. And then we basically just append that to the subdomains. We do a little bit of math to figure out like the length of the top level domain, and then whatever space is left over, we encode information into there, and then we number all of those packets or all of those messages, and then we send them all in parallel. So we might send like 1,000 DNS queries in like a second, because we're really just, you can easily detect this stuff, so we might as well just try to do it as fast as possible, because DNS is usually really slow. And we'll even do it across multiple DNS resolvers. So if we detect the machine has a secondary or a primary, secondary, and tertiary DNS resolver, we'll use all three, or however many it has, we'll use that number. And we'll just send them in parallel, and then the server sorts them and reconstructs the whole message and decodes it. So when you're doing like a full tunnel like that, there's no getting around like I need to send some number of bytes, which is going to, if it's more than like 10 bytes, honestly, even 10 bytes would probably be easy to detect. Anybody looking at the DNS logs or DNS traffic, it's trivial to detect that. But a lot of places don't look and don't have those detections set up, and they may not even have central repositories for DNS logging. And if you don't have those, then DNS is very effective and can be very difficult to detect because one, we use a pure Go DNS client implementation. So we're actually generally not going through the operating system to do these DNS queries. So that minimizes the amount of telemetry, especially from like an EDR standpoint. Because those operating system hooks aren't getting called. And so we're just sending the actual UDP packets to the resolver and getting the responses back. If you're logging on the DNS resolver, that obviously you're still going to see everything there. But so we kind of reduce telemetry there. But if you're not looking, that's going to be really hard to detect. And it's one of two indirect C2 protocols, the other being HTTP. So I would make a distinction between like direct and indirect protocols. So things like WireGuard and mutual TLS require like a layer 4 connection to the actual server because they're end-to-end encrypted, right? Like we need an underlying TCP, like the actual TCP connection between the implant and server can't really go through any intermediaries because it's mutual TLS, it's end-to-end encrypted, right? With DNS and HTTP, with DNS, you can go through the resolver, right? So I don't need a direct UDP like socket to the C2 server, which can be very useful because the implant is never sending layer 4 connections to the C2 server. So that can be very advantageous from a detection and telemetry standpoint. And then with HTTP and HTTPS, obviously you can go through a proxy. There might be like a corporate proxy like Zscaler or something that you have to go through. And so that's like kind of another indirect C2 protocol because you don't necessarily need the underlying layer 4 connection to establish communication. Whereas with WireGuard and mutual TLS, you actually do need those connections. So if the egress rules don't allow TCP to egress directly, which you do run into, a lot of enterprise networks will basically just block everything. And if it's HTTP traffic, it has to go through the proxy, right? And so Sliver will even continue to work in those because we have these indirect options. Yeah, there's kind of a crash course on selecting the proper C2 protocol as well, is you really want to analyze the egress rules and determine, and you can actually define fallbacks. So you can actually embed multiple C2 protocols into a Sliver implant, and you can define the order in which the implant should try them. So you can try like mutual TLS, it doesn't work, fall back to fall back to HTTPS. HTTPS doesn't work, then fall back to DNS. So you can define like a hierarchy that it should try too. So
that is a really thoughtful way of doing it. Like I wouldn't have thought of making it so that you can do multiple ways of egressing defined already. That's pretty cool shit, man. So I was choking on some water there.
That's okay. Sorry.
So the next question here comes from one of the audience members here, Tuna. Do the DNS implants lie dormant until they're called upon? How do you deal with the size limit by DNS?
Sure. So if the DNS, if you are like using DNS, it will abide by whatever rules you defined at compile time. So if you compiled it as a beacon, it will only send the DNS requests on the interval. If it's a session, then it will just, as soon as you execute it, it will call back. So the dormancy is user defined. And then the size limit. So we, like I was kind of saying earlier, what we do is we have a complete message. So in Sliver, they're called envelopes. So an envelope is a protobuf. We use protobuf because it's not a non-self-describing serialization format. If you use something like JSON, you have to use the same name for a field in the server and in the implant. But protobuf is not self-describing, so there's no names for a given field. And this allows us to improve the obfuscation within the implant, although some of the protobuf strings still get leaked. And actually, that's what most of the signatures are written on. But those are at least not necessarily needed at runtime to decode a protobuf message. So anyways, we have an envelope. The envelope contains a type, And then the type defines a data buffer, which has a protobuf message in it. And that way we know how to parse that data. So that entire envelope gets encrypted. And so now we have an entire encrypted envelope as a message. When we go to send that over DNS, which will almost certainly be larger than 254 minus the length of the top level domain, which is the most amount of information that we would be able to send, assuming we're encoding into A records, because that's the length limit of a DNS name. So we calculate that, whatever space is left, and we call it subdata within the code. And then we have to calculate how many bytes given the encoder that we're using, right? Because sometimes we use different encoders. So we have to calculate the encoded length, which is a certain number of bits that we're able to encode into that subdata region, which differs depending on what top level domain you bought. So we calculate that at runtime. And then we basically just chop the message up into those chunks and we number them. And then we send them all in parallel. And then when the server gets them, it just gets a chunk at a time. And then it knows the number. Since they're numbered, it knows the order in which to put them. And then it just reassembles the message and decodes it. So that's how we get around that. And that's also how we're able to send everything in parallel, which helps with the performance, which is typically not great. Even with sending everything over, sending all of the messages in parallel, DNS performance is still not necessarily great. But it allows us to squeeze a little bit more performance out of that connection. And so, yeah, anyways, that's how it works.
Cool.
Next question's mine. So Sliver's large binaries and Sliver.proto strings create static detection points. And when renaming protocol buffer messages like screenshot request to SC shot request REQ, how do you prevent breaking internal framework dependencies or like third-party tools like Armory extensions?
So really, the long-term answer for the static detections is working with Garbel to improve the obfuscation, or we may implement our own AST obfuscation, which we've done a little bit of. But there, we really want like a procedural approach to solving that problem. There's always going to be static detections, though. It doesn't matter if you perfectly obfuscate all of the strings. And our opinion is that Sliver is a stage 2 implant, or it's designed to be a stage 2 payload. So it's never the thing that initially runs. You should always you should only ever be loading Sliver payloads directly into memory. At least in our opinion. Obviously, you can spit out a .exe and run it, but it's not very stealthy. So we typically rely on packers and stagers and stuff to avoid those static detections. Obviously, there's still some memory shenanigans that various EDRs try to play. We use other runtime tricks to evade those. And then it's open source, so obviously you can go in and rename and implement your own obfuscation too, which is often the most effective because all of the signatures are based on the publicly available code. So as long as you tweak it just a little bit, that's often enough to break the signatures. So us solving that problem is not even necessarily the most effective approach, because if we solve it and we post it publicly, then they'll just develop new signatures. So you should always be doing a little bit of tweaking yourself, hopefully. And again, if you write a custom loader and stuff, which is how I would recommend using the framework, your primary exposure or your radar cross-section to detection is primarily going to be that stager or whatever that stage 1 execution is, and not the DLL. And so that allows you to play a little more loosely with the obfuscation and the detection within the implant. But so anyways, we'll probably clean up those strings at some point. Like I said, I haven't had too much time to work on Sliver in maybe about a little over a year. But the strings aren't necessarily needed at runtime either, because again, protobuf is non-self-describing. I think the Go library still uses them for some type of reflection, which is why Garbel can't necessarily accurately obfuscate them. Is like reflection is very complicated, especially at compile time. It can be difficult to know like what's being used if there's reflection involved, because by definition, reflection occurs at runtime. So that's why Garble kind of struggles to obfuscate some of that stuff. So, however, Sliver generates the source code and compiles from source. So you can go in there and tweak that all day long. And as well as with external builders, we especially in 1.6, we've made it a lot easier to just wholesale replace the implant if you want, or wrap it in additional layers of your own obfuscation and packing and things like that too, because basically the entire config is just sent to the external builder. The external builder returns some artifact that we don't even necessarily know what it is. And so that allows you to sort of define your own things in sort of like a build pipeline to address that. So hopefully, is there another part to that question? I think I answered it. Let me know if I didn't answer it.
We got an
definitely
answer.
answered it. Oh yeah.
Yeah.
Or a
When
response.
it comes to your behavioral obfuscation, like researchers that bypass EDR detections by disabling Donut's AMC bypass using like custom shellcode loaders, how do you balance backward compatibility with the need for like continuous evasion in a tool that's used by multiple operators?
Our stance on backwards compatibility is best effort. Honestly, when it comes to like the donut thing, again, like I just haven't had time to go add the feature to like disable it. Like there's no reason, again, it's open source too. But yeah, there's a lot of like pretty simple things we could probably do. Again, there's just so many hours in the day, and I have other projects I've been working on. Again, I'm hoping to come back soon though. But yeah, when it comes to Donut, it's just like when we initially implemented it, like we just forgot to add the option, or we didn't have time to add the option to like pull that thing out. So it's great to see. Also, again, if we do it and we make it public, they're just going to write signatures for whatever the public version is. So again, often what is going to be most
effective. You should do it and just send it to me, and I won't give it to anybody. It'll be fine.
But yeah, often you'll find it's just going to be more effective if especially if it's just like a little tweak like that. It's always going to be more effective if you do it and the public version doesn't. So if you do find those little tweaks, like just again, if we do it, it's great if you upstream it. We love features, but whatever it's always going to be possible to create detections, right? Like the detection cat and mouse game. It's just the nature of writing code and malware and everything. There's no way we can write a perfect obfuscator. It's not possible. Even if you do, there's runtime detections, entropy detections, behavioral detections. There's all sorts of stuff.
Yeah.
Like it's always going to be possible to write detections.
And
But
then you
those
get caught once, and then everybody else knows how to detect you after that.
But actually, I think one of the advantages of Sliver is everyone focuses on the public version. So as long as you tweak very minor things from the public version, you're going to break a lot of those detections with probably pretty minimal effort. So, but yeah, again, feel free to upstream us features. I think I did read that article about Donut. There's a couple bugs on GitHub about it too. But yeah, we just haven't had time to go add the feature. It's not that we don't want to or don't know about the problem. It's just that we also, going back to Sliver is designed as a stage 2, we have a lot of packers and internally written extensions that we use Sliver with. And so a lot of times these also just aren't problems for us. And a lot of times the problems get fixed when it becomes a problem for us. And not if it's not a problem for us, we're going to probably deprioritize fixing it.
So one of
Great
these
answer,
days,
man.
Yeah.
Future proofing, entropy masking, procedurally generated HTTP or HTTPS C2 introduces variability, but EDRs can flag high entropy in HTTP headers. So how are you minimizing entropy without sacrificing flexibility?
The encoder is randomly selected as well. So the entropy will be based off of the encoder. And like I mentioned earlier, one of the encoders we can use, it can be user defined. So you can define your own encoder functions. So that puts you in full control of the amount of at least entropy on the wire, assuming that's what we're talking about. But also like the English encoder, again. Now, again, a kind of an interesting nuance there, though, is obviously we're sending encrypted data. Encrypted data is always highly entropic. But basically, the way that you defeat entropy checks is inefficient encoding. So for example, the English encoder takes 1 byte and encodes it into like a 7-letter word, which is like 7 bytes, right? And that inefficiency is actually how you get around the entropy, because if you make the message bigger with lots of like consistent data in it, you reduce the entropy, even though you have the same amount of entropic information that original encrypted message. Since you're not encoding it into the same number of bytes, you can reduce the entropy that way. Also recently patched, we don't necessarily send everything in a single header. So if you look at the way, by default, using the procedural generation, Sliver chooses, I think, from like 7 different encoding methods. The encoder is identified through an encoder ID. The encoder ID is multiplied by a random number. Then we take that random number and we modulo it by the encoder. We basically kind of use a discrete logarithm thing where, if you take a number and you multiply it by a random number, and then you do modulo prime, like as long as that original number is prime, you can get the original number back by doing the modulus arithmetic on it.
You don't use lava lamps?
Yeah, we don't use, no, we do use cryptographically random data, but anyways, that way, whenever we send the encoder ID, that ID is different each time we send it. So if you look in burp at like the HTTP traffic, there will be like basically 0 bytes in common between different requests, and you can redefine each part of it too. So for example, by default, it'll use like JavaScript extensions. So like .js will like indicate like a certain request type, and then the path is randomly generated. And basically I had ChatGPT generate a bunch of random path segments for me. I think there's like 200 in the default one. And so it'll randomly select a random number. So the length is also randomized. And so one of the only signatures I've seen recently was they were looking at the query parameter, which is like the encoder ID, which I kind of question how accurate some of these are. But in theory, you can kind of look at that. So in a recent patch, we allow the user to define where the encoder ID is sent in the HTTP request as well, which sort of further complicates writing signatures for it. But again, if you're concerned about those things, you probably want to just define your own encoder methods and stuff. What we want to also, detecting the stuff on the wire is typically more difficult than detecting the binary on the endpoint. So most of your exposure to detection is going to be that binary. And again, that's why you want to use loaders and stagers and stuff. While it's possible to write wire level detections for some of the Sliver C2 stuff, it's just way harder to implement. Especially in large enterprises, like running like a bunch of regular expressions across like millions of HTTP requests in a day, like looking for specific things, is like difficult. Is a difficult problem. It requires a lot of computation. So what we want is for it to just be non-trivial to write wire detections. If you have to use like a regular expression or something, I consider that a win because of the resource imbalance it takes for me to execute the implant versus the blue team to detect it. Because now you need to run a regular expression across millions of requests to detect my traffic. And if you have to do that, it requires an immense amount of computation, which most organizations aren't going to do. So I would consider that a win still.
Would Rita detect it?
Possibly. I haven't tried it with Rita. Rita more looks at timing intervals, is my understanding of how Rita works. So Rita tries to detect the beaconing by looking at the interval timing between certain types of requests. So that certainly might detect beacon mode. You can introduce jitter, and you can dynamically reconfigure the implant too. So that's probably the way to get around it. Is maybe I might add a feature to like only activate during like business hours or something. Could be cool. But the way to get around Rita is to probably introduce a large amount of jitter, although my understanding is it can deal with some jitter. But if you introduce a large amount of jitter and switch between multiple domains, which is kind of possible today, but not super easy to use. Like if you can point like 20 different domains at the same C2 server. And what we could it's tricky to do today, but you could load balance across all of those. So that way each check-in is going to a different domain, and that's going to make it a lot harder for a tool like Rita to detect. like I said, we could probably make a feature like that easier to use. It's not really easy to do today. Like if you know how to write code, you could probably do it. But yeah, that's how I'd probably get around Rita is something like that. But again, when it comes to detections, it's more about creating like a resource imbalance between you changing something and the blue team detecting it, right? Like you want to create a large resource imbalance to make those detections not scalable. That's probably the best you're going to do.
Right.
Decentralized infrastructure request here, cloud native C2. So like, as you know, cloud-based C2 is becoming more of a priority for attackers who are looking for scalability and anonymity. Does Sliver's roadmap include like native support for serverless architecture, like AWS Lambda or Azure functions, or even make like maybe something like a blockchain-based C2 channel to decentralize infrastructure and like complicate attribution?
No, it's the short answer. For serverless, there's a very good Docker file for running containerized instances of Sliver, which you can use on Fargate, which is like AWS's serverless containerized application infrastructure. It would be a significant effort to port it to Lambda, just because Lambda has that execution limit, and Sliver deals with gRPC and persistent connections and stuff. So it would be a significant re-architecture to support something like Lambda. So I'd probably leave that to a different framework to do something like that. Non-attribution is kind of interesting because from a red team standpoint, we really kind of only care about like one hop. Like in a professional red team, your threat model doesn't include subpoenas, right? Because you should stop the exercise before contacting law enforcement, because like you don't want to waste law enforcement time on stuff that you know is like legal, right? So when you get into like one, I actually don't think blockchain is that the blockchain. There's a very nuanced conversation to be had there about anonymous, right? Because Bitcoin, the preeminent example of blockchain, is not anonymous in any way. Definitely not.
Mhm.
It's not private. I can cryptographically trace every transaction, right? So like there's an interesting distinction between anonymity and like privacy and stuff, especially when it comes to blockchain technologies, because the ledgers are generally public. There's technologies like Zcash and Monero that try to address this. But generally speaking, just because you're using like a decentralized protocol like a blockchain, there are no inherent properties around privacy or anonymity in that. You can build them in, but there's no inherent property around that. And it may make you more easy to detect. Peer-to-peer protocols typically aren't super difficult to write detections for. So it's not inherently going to fix that problem like either. Although it would maybe be cool to add a peer-to-peer protocol at some point. You might be interested in something like RatNet, which is another cool Go open source protocol that does sort of focus on some of these problems. But we from a red team, from like a professional red team standpoint, we really only care about like maybe one hop, because again, our threat model doesn't include subpoenas and seized infrastructure and stuff like that. We also like have very detailed recordings of everything. So I actually don't think Sliver is actually that great for like committing crimes, because we like cryptographically sign everything and attribute it. And we make very detailed logs of everything, which you probably don't want in a criminal enterprise. So I actually kind of laugh when I see a lot of articles about that stuff, because there's a lot of stuff in Sliver that you don't want if you're a criminal. So
Man, I tried to find that article, but I couldn't find it. But I remember a couple of years ago, Sliver was top 3 of nation state attackers.
Yeah.
Oh yeah, Cozy Bear uses it, and so does Exotic Lily and Shat Hack. Like
it
all
all comes down to your threat model. Yeah, because those guys also don't really care about subpoenas, because they're not going to, they are the government. Like no one's going to come get them. So it's only like sort of the middle criminal users that care about things like subpoenas and seized infrastructure. But anyways, so I mean, anyway, yeah, it's a dual use tool, but yeah, so we don't put a ton of effort into like anonymity and stuff, you could pretty easily tunnel all this stuff over Tor yourself if you want to emulate like a threat actor that uses Tor. But again, like Tor endpoints, not exactly the most difficult thing to signature. So you kind of, there's
Correct.
some trade-offs there too. But anywho, that's
So
kind
my
of my
last
standpoint there. So
question.
yeah.
My last question for you. Sliver's both free and open source, unlike many commercial C2 frameworks. What philosophy or principles drove you to release it this way, and how do you balance the democratization of red team tools with the risk of adversaries weaponizing them?
Well, I don't think the adversaries need Sliver to weaponize anything. Like I said, they have very different motivations than a professional red team. Like they're perfectly fine YOLOing all the data over Netcat raw TCP. Doesn't matter. You know, like they really don't care about transport encryption and all this sort of, and like, so like those use cases are actually quite specific to professional red teams. And so we really wanted, like, one, I've been a big fan and big supporter of open source for a long time. Especially the initial versions of Sliver, I wrote entirely on my personal time, just to, like, as a fun side project. And that made it easier to release as open source because I didn't have any sort of like commercial obligation time-wise. Luckily, Bishop Fox has been gracious enough to give me time to work on things since then, but at least like the initial versions were all kind of like written on weekends and stuff. So yeah, anyways, getting back to the question, I don't really see like the threat actors don't need any help weaponizing stuff. Like they're perfectly happy using, C99.php and Netcat to get all of their work done. But it's, professional red teams can't do that. Or at least not without adding an extra layer of security, right?
I was always under the impression that you want to use Sliver to kind of like get past a firewall or, that stage 2 loader to get out.
Yeah, I mean, it can be very useful. I mean, I would say that use case applies to all C2 frameworks, right? Like any C2 framework you use, you're going to want to get out of the network.
But this one's better than the others.
Maybe, yeah. I mean, it solves specific problems that I had as a professional red teamer. Again, I think those limitations don't necessarily always apply to real threat actors, though. Like if you look at a lot of the organizations that are being targeted by like ransomware, for example, they don't have SOCs. They could use Netcat. There's no egress firewall. You could Netcat right out to anywhere you want, So you don't need Sliver. It'd be like killing an ant with a bazooka. Like you don't need it. Sliver is mostly useful for targeting sophisticated organizations that have like security teams and stuff like that. So I guess maybe there's like a slight difference there, but nation states know how to program. Like my hobby project is not, I don't think makes a huge difference. And so, they're perfectly capable of writing their own implants too, right? Also, apparently Western governments, I've heard, also use Sliver. So I'm subsidizing everyone, not just the threat actors. But yeah, and there's a bunch of other open source projects out there. Really, I mean, Metasploit includes exploits. Like Sliver doesn't include any exploits. It has no means to get you onto the box, right? It's purely a post-exploitation framework. You have to use other means to get onto a box. So from that standpoint, again, once you have code execution on a machine, the implant to me is secondary.
Yeah, it's already game over.
It's pretty much game over at that point. Like Sliver can't do anything that your execution context can't already do, because again, it contains no exploits. So it won't allow you to do anything you can't technically already do given some execution context. So from that standpoint, I think things like Metasploit are actually far more dangerous because they actually contain exploits and stuff. So
because to contrast, like let's say you get an interpreter shell back, you could actually run exploits through that tunnel onto the box.
Yep. Which we have TCP forwarding, so you could potentially do something similar, but you still need that exploit. And actually, you can Metasploit actually allows you to specify external payloads now, so you can actually specify Sliver as an external payload, launch a Metasploit exploit, and get a Sliver session back.
Oh, no shit. Okay.
Yeah,
cool.
They actually added a feature kind of for us to specifically force Sliver to do that.
I was going to ask how you
So-
pass your shell
yeah.
over to it. That's great.
Yeah. So,
Uh.
yeah, Rapid7 has a nice little blog post that talks about how to do that. So yeah, like from my standpoint, I don't see any problem with releasing command and control frameworks as open source. I think if you look at the cracked versions of commercial C2 products, the commercialization is not really a barrier to entry for certainly well-resourced and even not well-resourced threat actors. Like Cobalt Strike is used probably more than Sliver in malicious use cases. So it's not clear to me that,
It was
that
number one.
restricting, yeah, it's not clear to me that restricting Sliver in like a commercial way would be an effective means to control its use anyways. So that said, I don't think there's anything wrong with like commercial versions of stuff. Like it's perfectly fine to charge for these. And also, again, when it comes to red teaming, like anything else, you want to use the right tool for the right job. There is no one C2 framework that's going to be the best at everything. We use multiple frameworks at Bishop Fox, not just Sliver. You want to be analyzing the situation, thinking about it critically, and using the most appropriate tool to solve that problem. And hopefully, you know, Sliver addresses a lot of the use cases that we had, but like I said, we use other frameworks. We're very happy with other frameworks. We don't just use Sliver because we wrote it. Sliver is good at certain things. It's not great at other things. You really want to be, again, thinking critically about the situation that you're in and apply the most correct tool to the situation, because all tools are going to have their own limitations, their own advantages, their own disadvantages. And yeah, so don't limit yourself either.
Well said. So,
Dude, you are
that's about
intimidatingly
it.
smart. Just gotta say.
Oh, yeah, he
holy
is.
shit.
The first time I met him in college, dude, Joe, you remember like you go up the stairs and you make a left and there's that handrail and a table there? You
Oh,
were
yeah,
sitting
yeah.
there on your laptop and I started chatting you up and I asked you how many programming languages you do and you said 12. And I was like, what?
I like to write code, you know, and I don't know, but honestly, once you learn 2 or 3 programming languages, it becomes a lot easier to learn others. So it really snowballs, like, because most programming language, I mean, there's a few different styles of programming languages, but once you learn 2 or 3 and like the different like functional, object oriented and like procedural languages, it's so much easier to learn new ones, like drastically. So anyways, don't be intimidated by that. Like the amount of effort it takes to go from like 3 to 12 is way less than it takes to go from 0 to 3. So
Yeah. I usually tell people that like, I don't know, what's your opinion? I think Python's a good one to start with, to start thinking programmatically.
absolutely, I recommend Python to most folks as a first language. I think Go is a good second language. I actually don't recommend learning Go as a first language, although I mean, it's not a terrible first language, but Go has like very sort of like somewhat unique concurrency properties to it. And I think you want to have a more sort of like standard understanding of concurrency with like threads versus async versus multiprocessing, which you'll get from Python. And then once you understand that, you can get into like the more nuanced things of like a Go routine versus a thread, which are different things in Go. And then like in JavaScript, where you have like a single execution thread, but then logical concurrency versus async. I think JavaScript and TypeScript and Go are good second languages because of that. They have some of these like unique properties that aren't going to be, that you kind of need like a conceptual understanding of like program execution before you can really take advantage. So I think Python's great. Because also it's useful. I still write Python to this day. So it's a great first language because it'll be useful throughout your programming career and journey. And it's like very easy syntactically to pick up. It has a lot of like really great features in it. The package managing could be improved a bit, but you know,
Yeah.
that it's a great first language. I still to this day recommend Python for a first language.
So I got a couple more questions for you. Sure. What's the favorite talk you've given so far in your career?
In my career, the favorite one I've given, probably, I did one on C2 design. I think I gave it for DevilSec, which is like the ASU security club. But I also gave it at LabsCon, which is like a blue team sort of conference, which was fun. I hadn't been to that many like threat intelligence conferences before. But that's probably my favorite. And it just goes into like C2, like what to consider when designing C2 stuff, or like your own C2, like what sort of, kind of going back to the WireGuard discussion, like single round trip key exchanges are like very good from an anti-fingerprinting standpoint. And that's certainly something I learned along the way. And so I think C2 design, I might like at some point write a guide to like C2 design in the Sliver docs, in how to think about it. Because I think a lot of the like fancy C2s are commercial and like don't necessarily go into great technical depth around design choices and why you might make them. And so there's been some great work on this since, in the last, I don't know, 5+ years. Like Mythic is another really great open source framework.
That's number 2.
Like great work there. They've done a great job of sort of like different design choices, right? Again, going back to you should use the right tool for the right job. They chose very different design approaches than I did. And there's nothing wrong with that. You want both in your tool belt, but I might write something about at some point, or a bit more, because that talk was about like design choices and trade-offs between them. And so, yeah, I might write something a bit more detailed on that someday, but
I implore you to do so. I'd be interested to read it, and I think everybody else would as well.
Yeah.
So, what's your favorite conference?
Favorite conference? I really like Objective by the Sea, which is an Apple product security
I haven't
conference.
been to that one yet.
It's actually in Ibiza. I won't be able to go this year because I'm getting married. But I actually proposed at Objective by the Sea. Yeah, thank you. But that's probably, it's a bit smaller. So I actually like the smaller conferences. Like, I like DEF CON. I've been going since like 2009, I think was the first time I went to DEF CON.
Yep.
So I love DEF CON and everything. Like, I love the big conferences, but I tend to have more fun at the smaller conferences because there's more opportunity to talk to folks and get into technical discussions. Whereas like DEF CON's a zoo, which is fun. Yeah. Oh, TourCon was great too. Yeah. So yeah, but OBTS is probably my favorite. Really good crowd. It's a smaller I think they cap it at like 200 people. And I like Apple products and I like hacking Apple products. So it's always like an interesting conference from that standpoint. But yeah, that's currently probably my favorite. Although, like I said, I won't be able to go this year, but next year I'll be there. But yeah, go party in Ibiza for me. So.
All right. Here's a funny one for you. Have you heard about recursion?
I have heard about recursion. Have you heard about recursion?
Yeah, recursion. What have you heard about recursion?
I've heard about
I don't know. Have you heard about recursion?
I can't
Stack
remember.
limit exceeded.
I can't remember if that was at Black Hat or at school, but you made that joke.
I was at school.
Stuck with me
It was definitely at school. I remember that being a meme when we were in school. So.
And then us working Black Hat, and you started doing the Russian stuff. We're stuffing bags for the motherland.
Yeah. Well, we were basically in a workshop, so I figured we should sing like communist hymns or something. I don't remember what the context, but we were like stuffing head bags for Black Hat. And I was like, this is like I'm in a Soviet Union assembly plant.
Sweatshop.
Yeah. So
good times.
Yep.
But all right, man. Congratulations on getting married.
Oh, thanks. Yeah. Looking forward to it. So.
But I think that's it for me. Anybody else got anything?
I guess you could say you seized the means of production.
Yep.
Now he also got root, and now I'm wondering what the implant's going to look like.
Okay, so we have a question from the audience. Exalted wants to know any books or recorded talk recommendations you would like to share.
Sure.
Learn Python the easy, or learning Python the hard, or what was it?
Yeah, Learn Python the Hard Way is a great online book.
Way
for
better than learning it
Python.
the dumb way like I did.
Yeah. Book-wise, though, I would recommend one. The Tangled Web is actually one of my favorite security books. It's a bit old at this point, and it's about web security, not anything to do with. Yeah, Sledge has
You
got a copy
actually
there.
recommended me this, and I bought it.
Yeah, it's a fantastic book. It's a great way to just think about security, even though a lot of the info, I think it came out in like 2011. So a lot of and the web has changed quite a bit. So a lot of the information in it is a little dated, but I think it's a great way to understand how to think about security, because the book doesn't really talk about like finding vulnerabilities or exploits or anything like that. It's more like, this is the RFC. These are the different implementations of that RFC. These are the ambiguities and where like weird security implications come from, like people's from the RFC being like ambiguous and people interpreting it and implementing it slightly differently. So I think that's a really great book for that. I also really like The Art of Software Security Assessment, which again, I don't think is in print and is kind of an older book, but it's really great way to go about source code analysis, especially chapter 4 is very, very good. Highly recommend it. And more recent books, I guess I can recommend more modern books. Writing an Interpreter in Go is about how to implement like an interpreted programming language using Go, which one really is a great way to learn about programming language design and interpreter design. It's a good way to, it's sort of like an intermediate Go book. So if you know a little bit of Golang and you want to learn more, it's a really great book for that. And I haven't read his follow-up. He has a follow-up that's writing a compiler in Go. I haven't read that one, but the interpreter one is very good. Highly recommend it.
Violent Python is good. And
also
so
a little
is
out of date.
Automate the simple things with Python.
The boring
I like
stuff.
that one.
Automate
the boring stuff. Yep, that's a good one.
Both very good. Violent Python's a little outdated at this point, but also quite good. I've read a lot of books, so. But yeah, any of the no start stuff is also very good. Black Hat Go is also quite good. That's a more recent book. I think it came out maybe 4 years ago now. But also a great book, again, on Go. But really, all of the no starch books are fantastic. Not just the security books. I highly recommend their other books too. Like a lot of security people only ever read like security books and stuff. I would highly encourage you to learn about other things. It's all connected. It's all made from the same stuff. It's all bits and bytes. Having an understanding of non-security things will only enhance your understanding of security. So that's why I'm also like recommending How to Write an Interpreter in Go. It has nothing to do with security. Will absolutely improve your understanding of programming languages and how to find vulnerabilities and stuff. So
the thing with security books, by the time you get around to reading it, it's going to be outdated in some way or another.
Well, all of tech moves very quickly, but security especially. But that's why I recommend like the Tangled Web more from like understanding a conceptual approach to security rather than like the literal content in the book, you know? So. And actually, his other books are quite good too. Silence on the Wire is a really great read as well. And again, more for like a conceptual approach to problem solving than like necessarily like direct content, but gets you thinking more creatively. So,
if my foot wasn't broken, I'd go grab a stack of books and show you.
Yeah.
Please don't break your foot again, Sledge. Well, re-break your foot again. Let me reword it like that.
No regrets.
Maybe listening to that doctor was a regret, let's be honest.
Yeah, he re-broke it.
That one was not you. It's fine, it's healed. No, it's not. Yes, it is. No, it's not.
Falls on the ground.
Exalted says thank you. People have been enjoying the cast with all kinds of lovely compliments. So thank you, everyone, for welcoming our guest, and thank you to our guest for being
Thanks for having me.
Freaking awesome. I've been silent because I can't even be witty. I've been blinded with science. I'm normally the asshole here that's here for comedic relief to keep things from getting too dry, but I'm just over here like mouth half agape, a little bit of drool coming out the side.
Joe, one more question from me. Are there any roles open at Bishop Fox that would result in somebody working under you that they could learn from you?
You should check the website. I'm not sure what positions we have current. My fiance is actually one of the recruiters, so I really should have a better answer. But I think we are hiring for certain roles. We just filled several on the red team specifically. So I don't know that we have any open on my team right now. I think there's a good chance we'll be hiring later in the year, though. But everyone at Bishop Fox also collaborates, so I think it's a great company to work for. So definitely check out the roles and check back to, like I said, we just finished. We're kind of in the slow period, we're consulting, and Q4 tends to be the busy season, and Q1 and 2 tend to be a bit slower. And so we're just hiring less right now. Come Q3, Q4, we're going to be hiring a lot more again. So definitely check back if you don't see a role that piques your interest. There'll probably be more positions available later in the year. So it's just the sort of the cycle of consulting.
Mm-hmm. Absolutely. You're in the red team, correct? So somebody we're looking to apply.
I'm the managing principal. I'm the managing principal on the red team in the consulting org. Bishop Fox has two main orgs, the managed security services team and the consulting team. So the red team is within the consulting org. But we don't exclusively work on red team projects either. I also, like I kind of said earlier, I spent 10 years in AppSec. So I do a lot of app pen testing too. So I often collaborate with folks who are not on the red team. And then I also develop a lot of the internal tools that Bishop Fox uses, and those are also used by non-red team folks. So,
excellent. Well, you've answered all my questions, and I think Sledge has pretty much run out of questions. So I'm beat. Man, this has been a great interview. I'm not even going to do the InfoSec news this week. I think we've gone far enough at an hour and 46 minutes on an interview. I've had a great time and learned a lot just by talking to you. So I want to thank you again.
Thanks for having me.
On to our cast.
We're not even halfway to our record of 4.5, whatever, how many hours that was.
To be fair, half those hours were dad jokes. I mean, that sometimes that's just what happens. But this has been pure content.
But anyways, Joe, it's been awesome catching up. Hope to see you at the next conference. Thanks for coming on.
Do. Have a good
I'll
one, guys.
see you around.
Talk to you later.
I'll remember everything you told me when I'm using your stuff for chaotic good.
Please do. All right, have a good one. Talk to you guys later.
Bye.
Take care.
All right, hackers and cyber warriors, it's time to encrypt this episode and send it out into the digital ether. Thank you to Sledge, Delchi, CrowdStrong, and Altkey for another epic nerd out session. And a special thanks to our guests for joining us. And to all our listeners out there in the cyber trenches, patch fast, encrypt tight, lock down your ports, and leave no backdoor open. Hunt threats like it's open season. Keep your passwords long, your MFA enabled. Don't use SMS as a second factor. Keep your malware signatures up to date, your critical data backed up, and your network locked down like Fort Knox. Until our next PunFest, stay vigilant, stay curious, and above all, stay counter-surveil. Whether you're pen testing networks or hardening your own defenses, remember, in the game of cybersecurity, you're either the hunter or the hunted. So sharpen those skills, mask those IPs, and we'll see you on the dark side of the net. This is Counter Surveil, where we turn paranoia into preparation, shutting down but never logging off.